telomeres are the very tips of your chromosomes. Your chromosomes are where your genes are. They're encoded on a molecule called DNA. Well, DNA is like a long string of beads. And think of these long string of beads as a shoelace. The beads are called bases, and a typical chromosome is about, or a typical DNA molecule inside a chromosome is about 100 million bases in length. Well, think of that as a shoelace, as I said. The caps on your shoelaces are the same as the telomeres on your chromosomes. So on this long string of beads, the very tips of these things are called telomeres. And they protect your chromosomes the same way that the caps on your shoelaces protect your shoelaces. Now, the size of these telomeres is about 15,000 bases. Remember I said the chromosomes, the DNA in the chromosomes is about 100 million bases in length. The telomeres are only 15,000 bases in length. And that's at least how long they are when you're first conceived. And here's where all the problems begin. And it's all because every time your cells divide, those telomeres get a little bit shorter and shorter and shorter and shorter. So as I said, when you're first conceived, your telomeres are about 15,000 bases, but there's so much cell division that's needed to make a newborn baby that after all these cell divisions, your telomeres have shortened down to 10,000 bases. That's okay. I mean, the telomeres are still long enough to protect your chromosomes, but the problem doesn't end there. As you start to grow up, you have more and more cell division, your telomeres continue to get shorter and shorter and shorter, and when they get down to about 5,000 bases, then all kinds of havoc is wreaked because your chromosomes start falling apart, they start having mutations, and these short telomeres cause your cells to senesce, and that's typically when you die of old age, when your telomeres get down to 5,000 bases. We know from scientific literature on human cells in petri dishes, we know from taking tissue samples from people at different ages, that when telomeres get down to 5,000 bases, the cells lose the ability to function and they die, and you die of old age. So that's what we have to do. We have to find a way to keep them from shortening and actually re-lengthen them. I had mentioned that every time your cells divide, your telomeres get a little bit shorter. There's nothing we can do about that yet. The cells just lack the ability to duplicate the very tips of the chromosomes every time chromosomes need to be duplicated during cell division. But there are things you can do to accelerate that shortening if you are somebody that thinks you're not aging fast enough. And these are anything unrelated to an unhealthy lifestyle. Because a lot of things you do cause the generation of free radicals or cause inflammation, and these things accelerate the rate of your telomere shortening. Things you can do to prevent that, so I call that accelerated telomere shortening. Things you can do to prevent the accelerated telomere shortening are, one is endurance exercise. Running, swimming, biking, anything related to endurance, as long as you keep it like fun and adventurous, that kind of endurance exercise actually decreases the rate of that accelerated telomere shortening. It's amazing how many people in their 80s are out there running long ultra marathons and looking like teenagers. It's just amazing how much endurance exercise can slow down the rate of telomere shortening and aging. But those aren't the only things you can do. There's supplements, vitamin D, omega-3 fatty acids, antioxidants. These things have already been shown in scientifically peer-reviewed journal articles to decrease the rate of shortening. People who take these things have longer telomeres than their friends that don't. And it's not because they are lengthening their telomeres, it's they're decreasing the rate of that accelerated telomere shortening. Reducing stress, reducing depression, being optimistic, all these things have been shown to decrease the rate of accelerated telomere shortening. But two things that are really important are smoking and obesity cause accelerated telomere shortening. So quit smoking and lose weight. These are really good ways to keep your telomeres as long as possible. But nothing that I just mentioned will lengthen your telomeres. And that's what I really want to do. I want to find a way to lengthen the telomeres so that we can make ourselves younger and healthier again. Well, we started off with discovering that, as I mentioned, every time our cells divide, our telomeres get shorter, but that's not true in our reproductive cells. Our reproductive cells, cell divides, the telomeres don't get shorter. And we discovered this enzyme called telomerase. Telomerase is produced in our reproductive cells, and what happens every time the cell divides, telomeres do get a little bit shorter, but then telomerase re-lengthens it back to the original length. Long story short, we have found that if we overproduce telomerase in cells, we find that the telomeres actually start getting longer, which was the first hint that we actually had discovered a way to possibly reverse human aging and declining health. So we took this enzyme and we put it into normal skin cells. Remember, it's only produced in reproductive cells, but when we put it in normal skin cells, we found that these cells stopped aging and actually became younger by every method of measurement you can imagine. We also took skin cells that were treated with telomerase and skin cells that weren't treated with telomerase, grew them into skin on the back of a mouse. Excuse me, these are human cells grown into skin on the back of a mouse. And we found out that the old cells treated with telomerase to lengthen the telomeres grew into young skin, whereas the old cells not treated with telomerase grew into old skin. Well, this was exciting. This was like 20 years ago. This is the first time we'd ever actually seen any type of organ actually get rejuvenated by lengthening telomeres. But I think the most significant support of the concept that lengthening telomeres can reverse aging was done just a few years ago by Dr. Ron DePinto at Harvard, where he engineered mice so that he could turn telomerase on and off inside the cells. Telomerase is encoded by a gene, and you have the ability to turn genes on and off just like a light switch. So he engineered them so he could turn telomerase on and off like a light switch in these mice. He let them get really old with this switch turned off. Okay, he got really old, telomeres got really short, the mice got really old. And then he flipped the switch on by feeding them a certain supplement, and it turned on telomerase in all the cells of the mouse, or the mice, and their telomeres all got longer, and these mice became physically younger by every method of measurement you can imagine. And so that's what we are trying to do with humans. We are trying to repeat this same kind of experiment with humans, looking for some kind of chemical or natural product, any kind of supplement that you can take that will get inside of all your cells, turn on the gene for telomerase, and make your telomeres longer. Well, we've been working now since 1999, so it's been, what, 16 years now. And what we're trying to do is we're trying to look for chemicals and natural products and practically anything that will get inside of human cells in a petri dish and turn on the gene for telomerase. We have tested, well, we first developed a very high throughput screening assay that we could test cells with, so we can test like 4,000 different chemicals a day, looking for something that would, when added to human cells in a petri dish, and then let the cells incubate for 24 hours, then the next day break open the cells and ask, did those cells produce telomerase? We have an assay that allows us to do this 4,000 times a day, all robotic and stuff. And so we started testing all kinds of chemicals at random. We tested over 300,000 different chemicals, actually found 900 of them would actually induce the production of telomerase at low levels. And we were able to then look at the structures of all these chemicals, or at least our medicinal chemists looked at the structures of all these chemicals, and were able to design new chemicals. Well, from just the random, 300,000 random, we ended up, our strongest hit was something called C057684, which was the 57,684th chemical that we tested. And we found that that produced enough telomerase inside of a cell to be about 5% of what we thought we needed to actually stop telomere shortening. And if so that would be like 100%. If we'd go higher than 100%, that would be actually lengthening it and reverse telomere shortening. But the strongest one we found was C057684 was producing about 5% as much telomerase as we needed. Well, that's a lot. It's still not anywhere near what we needed, but we then started doing the medicinal chemistry, looking at the structures of all these chemicals. And in a very short period of time, we ended up finding stuff that, at least one chemical that was 16%. We found a lot that were like 10%, 12%, but one was 16% of what we need, and we called that TAM818, telomerase activating molecule 818. And that's our strongest, in fact, it's the strongest chemical on the planet right now for inducing telomerase. We plan on doing a lot more research to even go higher than that as soon as we get more funding to do that. And I anticipate that we could be at 100% within about a year after we get the funding we need to do that research. The only one we've been able to really compare it to is TA65. TA65 has published data showing how much telomerase is produced when added to human cells in a petri dish. And we've been able to compare that published data with TAM818, and we estimate it's somewhere between 80 and 300 times more potent than TA65. Data is not available to compare the other things that are on the market. Well, the global financial crisis of 2008 hit everybody pretty hard, including the investors that we had. We were spending close to $1 million a month doing the research, and suddenly we didn't have any more funding. And it's been, since 2008, it's been very, very difficult to find investors. So we started thinking, well, maybe we can take some of the discoveries we've already made and possibly make revenue from those things to fund our research. And we were very fortunate, and I love the fact that a company in New Zealand called the Chase Life Extension Foundation actually licensed our strongest chemical from us, the one that I mentioned before, TAM818. And they have been successful at putting it into a skin cream that has been shown in clinical studies to actually be safe and efficacious. And as a result, they are now going to be, they've put it on the market, and we are now getting royalties from the sales of those things. And those royalties are all going into our research. And I'm looking forward very much to the fact that in just a few months from now, we expect those royalties to be enough to fund all the research that we need, and we can get back on track again. It had been kind of frustrating because we were looking all over the world for somebody that would be interested in marketing one of these products. Even though they aren't potent enough to actually reverse human aging, they're plenty potent enough to slow down the aging process. And we thought at first that people would be excited about this all over the world. But I really don't understand. Maybe people just didn't believe it. It just seemed too good to be true. But I'm really glad that the people in New Zealand actually licensed this, and because I think it would be absolutely wonderful if the cure for aging actually came out of the land of the hobbits.